In order to solve this task, we're going to have to create a separate function outside of the main method of our Java program. So in this case, let's set up a completely separate function. I'll put in the words private and static. You don't need to worry about those just at the minute. The interesting feature here is that we're going to have to return an array of integers from this function. Because the function is designed to transform a string into an array of integers, let's say get number array as the name of the function. Now, in terms of parameters, we're going to take in one single string parameter, which is the hex string, like that. So that's the infrastructure setup of our function. You could use the word public here as well, just for now. It doesn't really matter for a task on this scale, and since we're just working inside one Java program, for now we're not really doing anything significant or advanced. We'll just put the word static in there to make sure that this works, but comprehension of those two words isn't really required at GCSE level. So in order to progress, then we're going to have to iterate through each of the individual characters in the string. So it makes sense to set up a for loop. If I'm using like a NetBeans IDE, I can do FORI tab and it will set up a for loop for me. We're going to be iterating through all of the characters of hex string. So hex string is a string, therefore the length is not stored, so we have to call a method that will calculate the string length for us. And we'll strip out what's found in here because it's not really that useful. Okay, so we now have the ability to visit each of the individual characters inside the string. The Java language offers a second variety of for loop called an enhanced for loop, and it does provide us with an alternative way that we could solve this problem, but let's stick with this for now. Okay, so within the for loop, what we're going to be doing is progressively adding one element at a time to an array. So that means that we would have to set up the array in advance of entering the for loop, and also because arrays are limited in their abilities, we can't extend the length of an array each time in the way that we would if we were working with, say, a list in Python. So what we're going to do here is we're going to build an empty array of integers. We're going to call it nums, and we're going to say it's a new array of integers, but inside these square brackets we're going to have to state the size of it. So the size of the array is going to be an exact match for the length of the string, because each individual hex digit is going to occupy one element in there. Now, because we're calling the same function twice here and here, it might be an advantage to say that we only do it once, and then we just use the variable called size here and here in order to, number one, reduce the number of times we have to make the program do the same job, and also improve the readability of the code. Okay, so we have an empty array, and strictly speaking, it's not really empty. It's going to be full of just zero values at the minute if we were to look at it or imagine it in our heads. So what we're now going to do is we're going to iterate through all characters in the hex string. So in order to begin the process, we ask ourselves, how will we do the conversion? Each of the individual number characters in the ASCII or Unicode character set carries the values from 48 to 57, which means that if we were to convert the number from a character into being an integer, we would end up with a number that is 48 higher than the number itself. So we could use subtraction by subtracting 48 from the number. Similarly, if we were to stumble upon an uppercase letter, then that would mean that capital A is 65, capital B is 66 in the ASCII and Unicode character sets, and that would mean that we could subtract 65 in order to do the conversion. So in this case, we are going to have to treat these things as either numbers or letters and then do some sort of an adjustment. The thing is that the numbers are already available in number format. So if we knew that we had a number, rather than doing the subtraction, we could actually just parse the number. So the way that I'm going to approach this one is I'm going to begin by trying to identify whether I'm dealing with a number or dealing with a letter, because ultimately I'm going to have to deal with them in two different ways regardless. So let's begin by getting Java to work out whether the character is a number or is a letter. So we're going to visit the one particular character at position I. So we're going to go to the hex string and we're going to pinpoint the character using char@, and we're going to give it position number I. So if that particular character is greater than or equal to the 0 character and that particular character is less than or equal to the number 9 character, then that means that I'm definitely dealing with the number character. And the manner in which I do the conversion is then up to me. Do I want to extract it as a substring and then just parse it? Or do I want to take the character, convert it into its integer value, and then subtract 48? So in this case, because I'm going to use the subtraction technique with the letters, I'm going to use the same technique with the numbers so that it will improve the overall readability and maintainability of my code, because the same strategy will be used twice. So what we'll do is we will take the character that I have found there and we will typecast it into its integer equivalent like this. Now that we've found the value, we can put this entire thing into brackets and take away 48 from it, and that will give us our value. What we can then do is take that value and put it into the array. So we write down the name of our array, which is nums, and we pinpoint location I in the array, and we say that it becomes equal to that new value. Now, the alternative is that we will be dealing with a capital letter, and in order to make absolutely certain that it is a capital letter, what we're going to do is we're going to say that the hex string becomes equal to the hex string dot to uppercase. So I'll have to retype the dot and write to uppercase like this. This means that when we come to do the conversion, we can be fairly certain that it'll be okay. So let's follow much the same pattern as this one. So we are going to pinpoint the letter, the A, B, C, D, E, or F. We are going to typecast the character value into integer form, which means that it'll be a value starting at 65, and then we can take away, if we were to take away 65, that would bring it down to 0, but then we would have to add 10 because A is equal to 10, not 0. Now, taking away 65 and adding 10 is the same thing as taking away 55, and that allows us to solve the problem in a slightly different way. Okay, at this point, the for loop should have populated all of the individual elements that were originally zeros. So at this point, the array, whose name is nums, is now ready to return. So we can return nums, and that should complete the function itself. So if I just scroll down so that you can see more or less the entire thing inside the window, I'll take out some of these blank lines so that you can see everything all at once. Okay, so there's the complete solution there for the function itself. So it's now time to test it. So let's go back to our main method of our program. Let's take a copy of the function itself and let's generate a result. So let's build an integer array called test array, and let's say it will get the number array for the following string of hexadecimal values. Let's put in some numbers, 9, 0, 4, 6, 2. Let's put in some letters, A, B, F, E, and then continue to jumble letters and numbers like that. Okay, let's save it. Okay, now at the minute we are about to run it, so we will want to see the outcomes. So what I'll do here, just for convenience, is I'll do a simple for loop that will iterate through all of the individual elements, and here I'll do system.out.println by typing in SOUT tab, and then I'll simply move that individual value inside, and I will take out the ln so that they don't print in a new line each, and instead I'll separate them with a space, a comma and a space like that. It will of course put one on the last one, but I'm not so worried, it's only for testing purposes. Okay, so let's run the program, and what we're expecting to see then is the equivalent of this string. So the first 5 characters should be numbers 90462, and then it should give us 10, 11, 15, 14. There we go. 10, 11, 15, 14, and so on. So I'm generally happy that this is working as expected. I could probably take out that space in order to improve the readability of the output. I'll be able to see all of it on the one line. Now, there is of course the sense of, have we really finished this? What could possibly go wrong? Could this program be vulnerable to problems? And yes, absolutely it could. So the first problem would be, if it was up to the end user to generate the hexadecimal values, perhaps by typing them in, then they could put in some nonsense value like an X or maybe a piece of punctuation. So just out of interest, let's run the program to see how it behaves. And you can see that it does give a number value, and it's very convincing. It looks like it belongs there when actually it doesn't. So what we could do is we could get it to deal with this in the array somehow, perhaps by skipping that value. We would have to do the skipping by adding in an additional rule here. So previously we said if the character that we were looking at was greater than or equal to the 0 character and less than or equal to the 9 character, then we knew that we were dealing with a number. So we would need to take a copy of that, and we would need to specify that it would also have to lie in the range A to Z if we were going to do the middle portion of the if statement. And finally we would add an else block in order to deal with the final eventuality. And in order to do that, we could say, for instance, that nums at position I becomes equal to -1, because all of the other values in the array are going to be defaulting to 0, so we will want to put something in there that will flag up as a problem. This can then be dealt with in other ways later in the program. So depends what this function is actually doing in the bigger picture of things, and we may have to be careful if we come across any -1s. We may have to make an adjustment to the array itself. Okay, so that's generally a fairly complete solution to the problem. I do feel that it was outside of the scope of the task to think about every eventuality, and I would be happy to say that as long as the program works when it's given a valid hexadecimal string, that it's a nice feature that the letters were converted to uppercase, but even that could be an assumption that they're given as uppercase letters and numbers only, that they're all valid hexadecimal values, that the main bulk of the algorithm is now working.